In this lesson, we're going to look at linear versus nonlinear functions. So let's take a minute to classify things as linear or nonlinear. And the linear functions we can classify even more by if they are a proportional relationship or showing direct variation. So a linear function, what that looks like on the graph is that it's going to have a straight continuous line. More specifically, if you remember about these direct variation relationships or the proportional relationships, is that not only are they a straight line, but they are going to go directly through that origin, and that's what makes them proportional. Now, a nonlinear function on a graph might look something like this. It could be any line that is not straight. It could also look something like this. These are in a straight line, but it's not in one continuous straight line for that. All right, so let's go ahead and take a look at what the relationship looks like in an equation. Any linear function can be written as y is equal to mx plus b, where m is going to represent the slope and the b represents the y-intercept. And these can be written, you can have an equation that has just like y is equal to 2x plus 4. You could have the x on the other side as negative 2x plus maybe 5y is equal to 10. You can have a fraction. You can have something like y is equal to x all over 4 plus 5. And then more specifically, our direct variation equations, those are in the form of y is equal to kx, where k is the constant of variation. It's the rate of change. I also like to look at this as another way of looking at y is equal to kx is kind of like just saying like y is equal to mx plus 0. It's that slope-intercept form, but the m and the k, they represent the same thing. In the direct variation equations, though, the main thing is that you're going to have it will start and go directly through the origin. So some equations might look like y is equal to negative 4x. You might have y is equal to x all over 4. And one of the things I should have mentioned up top here is these linear functions, and we haven't talked much about function notation, but you might see something like this. All right, so I thought I'd better add that up top there. All right, so our nonlinear functions. These are the functions where in an equation, if you ever see an equation where you have an x squared, if anywhere in your equation you have a square root of your x, if you ever have an equation where your x is on the bottom, all of these are going to indicate that these are not linear. All right, so how do I determine if a relationship is linear from a graph? Determine if the graph is a linear function. If it represents a linear function, find the rate of change and determine if the relationship is directly proportional. All right, so for the first one, notice it is not in a straight line, so this is not linear. All right, for letter B, notice how it's in a straight line. And so yes, this is going to be a linear. And now let's find the slope. So I'm going to find 2 points. And so I'm going to go up 1 over 2. So my slope of this line is 1/2. So our letter C, notice this is linear. And more specifically, it goes through that origin. So this is going to be also directly, what does it say? Directly proportional. All right, and so let's just kind of, and then we need to find the slope. So our slope, we're going up 1 over 1. So our slope of this is 1. And for our last one here, notice it is a straight line. So that's linear. Notice that it is also going through the origin, so it's directly proportional. You'll also hear the direct variation. You'll hear just proportional. All of those things mean the same. All right, and then let's find the slope. Now we need to pay attention here. We went up, this is not 1, it's up 20 and then over 1. So our slope for this one is equal to 20. Example 2, how do I determine if a relationship is linear from a table? Tell whether each table is a linear function. If it represents a linear relationship, find the rate of change and determine if the relationship is directly proportional. All right, so let's find the rate of change here. All right, remember it's the change in the y over the change in the x. From 2 to 8, I went up 6, and the y, I have up 3. From 8 to 14, I went up 6, and then I went up 3. Now notice, from 14 to 22, I'm going up 8, and then I'm going up 4 here. So, all right, so let's make sure that we simplify these. So 6 all over 3 is equal to 2. Now let's do the 8 all over 4. Well, 8 all over 4 is also equal to 2. So in this case, the rate of change is 2. So this is going to be linear. And our slope is equal to 2. Now, it is not directly proportional because notice how you have 0, 2. It's going to be 0, 0 because it's going through the origin if it's going to be directly proportional. All right, let's look at our next one. Let's find our rate of change. I'm going to change in the y. I'm going up 6 and plus 2. All right, and here I'm going up 3, but then I'm going up 1. So I have 3 all over 1. Notice how that is equal to 3. And here I'm going up 3 and up 1. So 3 all over 1 is also equal to 3. So in every case, it is equal to 3. Now let's check and see. So yes, we know that this is linear. It start by going through the origin. It started by going through the origin. So it went through the origin and it has a constant rate of change. So we know that this is also going to be directly proportional. And our slope is equal to 3, or our rate of change. All right, so Mary earns $8 per hour babysitting her neighbors. Let's go ahead and write an equation that would model this relationship. So we have our y is equal to, and we just have $8 per hour babysitting. So we're just going to have y is equal to 8x, where x is our hours, number of hours babysitting, and our earnings would be our total, which is y. So let's fill in our table, and we're going to plug in 0. So if you babysit 0 hours, you're going to make $0. After 1 hour, you're plugging in the 1. 8 times 1 is 8. 8 times 2 is going to be 16. 8 times 3 is 24, and 8 times 4 is 32. All right, so what pattern do we notice? Well, we notice that it's going up by $8 every hour. Is this a proportional relationship? Well, yes, it is proportional. It started at the origin, and it's going up by 8, that constant rate of change. So yes. And what is our rate of change? Well, that rate of change was 8, that $8 per hour. Now let's look at our next relationship. It says Fred's Pizzeria charges $12 for a large pizza plus 50 cents for each additional topping. So let's write an equation for this relationship. So the total cost is going to be our y. And then we're going to pay that one time $12. So for a large pizza, you're going to pay that $12. And then for each additional topping, you're going to pay 50 cents. So that is going to be our change. So this is a linear relationship in which you're going up at that constant rate of change. So let's talk about if you have 0 toppings. Well, if you have 0 toppings, we still have to pay for that pizza, which is going to be $12. And now for each pizza or each topping, we're going to times it by 50. So I'm going to have 12, and now there's our first topping. Now if I have 2 toppings, that's going to be a total of $1. 2 times 50 cents, $1. So I have to add that then on. So I'll have a total of $13. And then it'll keep going up by 50 cents. So what pattern do you notice? We notice that it goes up by 50 cents. For each additional topping. Is this a proportional relationship? The answer is no, because it started at the 12. And what's our rate of change? Well, the rate of change is then 50 cents.